Not much. Just working on Quest 4 right now.
How's that?
It's a little tough. There's one thing I'm a little confused about right now. I don't know if anybody else has figured it out, but in like
So
the
what-
public section of the tree class,
Oh.
they have like a friend function that's like an overload for the like see out operator. And it says to do on it. I assume we're supposed to do that then, even though it says it's a friend class.
I don't know. I haven't gotten to Quest for him on Make Next Gen. So I solved the problem with my program, one of my functions. And
Nice.
just how I was converting the variable types. Like I was converting it from string to int when I so converted it to string to size t, but
Okay, yeah, those will get you.
yeah, I mean it technically worked, but I guess there was an exception in the test that didn't like it, so it was caught. But it doesn't really tell you specifically what it is. Like
Yeah. You're saying this is part of the make next gen function?
no. But I just started working on Make Next Gen. I would because I was stuck on that beforehand, but I got to main quest 6.
Yeah, very nice.
Yeah.
What were you saying, Ryan, that you were working on that you were having trouble with?
So inside there's like a friend function where it's basically like an overloading for like the see out operator. I don't know how what to call it, like a string stream. But it says it's a friend class, but then on like the spec it says to do. So I was wondering if like it's required to do, and if so, I guess like I was trying to think like how I would implement it, considering like you already have to string methods for both the node and the tree itself.
So those OStream operator overloads are typically friend functions
Okay.
because well, basically because one of your members of that function is the OStream operator, not a tree function. So
Right.
it has to be friend so that it can have access to the inner member variables of the tree
Okay, I
class.
see.
So yeah, you still have to do it. It'll probably be pretty simple once you have the toString functions done, because it'll just sort of be you'll be calling that. You'll use the OS. Yeah, it's called OS here. You'll do OS, and then you'll just treat that like you would see out, basically.
Okay. What
And then
so
sorry, go ahead.
like for the two string function for the tree, should that be because like what I was treating that was like I created an O string like in a string stream instance, and then I would just access the like whatever member variables of the class like just directly and then just stream them in. So are you saying I should put that section in the definition of the operator and then use the to string for the tree as like the actual like print method?
No, so like you would just do something simple, like it would be like OS. This is in the operator overload I'm talking about. You would just do like OS less than toString method. And then so basically whenever that operator gets called, like if you're in main and you do cout and less than, and you put in, you don't say toString, but you say like whatever your tree object is, it'll go into that function and basically like get the info from toString, put it into the cout, and do.
Okay. So it's so it's external. So that way the user doesn't have to call to string. They can just use the less than operator.
Yeah, exactly.
Okay, I see. Okay, cool. That makes a lot of sense.
So like once you have toString made,
Yeah,
the user of this class isn't going to want to type toString. They're going to do cout because that's what you do with everything. So this is just like
right.
putting the functionality of toString into the operator.
Okay, that makes a lot of sense. And so another question. So with regard to the actual operators themselves, like for example, I guess like for the node class, you have like the equality operator. So did you like, I was trying to think of how to design this. Did you design like those operators as being like sort of simple, just go through each member variable and check their value? And then was the is equal function like the one that was applied recursively, or did you switch it?
I haven't actually done them yet. I've just been, looking at it.
Okay.
The way I was thinking about doing it was that is there one called is equal?
Within the node class or the struct.
Let me look at that real quick. Oh yeah, I
Yeah,
see
they
that.
have a up equal equal in the node struct.
So I haven't done it yet. The way I was thinking it would make the most sense would be that the copy constructor is where for node, the copy constructor const node and that would be the one where you're like really doing the deep copying of a new node. And then if you did the equals operator, then it's just going to, oh, sorry, you were talking about the comparison operator?
Yeah, like not the assignment operator, the comparison.
Yeah. Yeah, it would probably just call the operator equals overload would probably just call is equal. And then the not equals operator would probably call the equals operator. So you can
Okay.
keep those really simple, and then is equal is where you'd be really doing the checking of all the different parts.
Okay.
But I haven't done it yet, so take that with a
All
grain of
right. Yeah, I think it's kind of like the quests are due like next Monday, but like for example, like quest 3 was supposed to be due like this morning. And so it's sort of like I don't know how to like do it where I can like get feedback unless I just like grind out during the weekend and then like come like a whole week ahead of time. So I don't know. I thought like maybe it would make sense if we move this meeting to like later in the week, but I know Monday is like a pretty good day. What do you guys think?
Not for me. Not for me.
Not for you.
No.
Not for you,
Like
isn't not for you what?
supposed
Like
to be
not for you
like
Mondays?
apparently there's supposed to be like some meetup at 1 to 2 p.m. But I
Okay.
have like a class like in that
Yeah.
time. And like
Yeah.
when I come home it's like at 4 and then I have to do stuff and then I'm here.
Yeah. Safe. I mean, I have work, so there's no chance I can do anything before 3 p.m. Pacific time.
I do feel
Um,
you about the whole meetings being on Monday, because yeah, it's like unless you do all of your work over the weekend. For the previous quest, like it's like during the week when you probably it's like we would probably have more to say.
right.
I think that's why we're probably a little more quiet on Mondays, because we're still like trying to figure out like maybe in the beginning stages of like whatever quest we're working on,
Yeah.
Yeah.
Yeah. I agree.
unless we're late.
I totally agree too. I don't know if like a shorter optional meeting, maybe midweek could be good, or I don't know. That probably would make me work on the next quest a little more quickly too.
Yeah, something like that. Like yeah, mid or something something Wednesday or later to just kind of not be like the beginning of the week.
Yeah, that'll help because I only treat this meeting as like I just got into quest 4 now and I just have like intro questions and that's it. I can't really help on quest 4. So yeah, midweek will be
Yeah.
great.
So I just have a question about Quest 3 because about make next gen and extreme bit. So does like extreme bit alternate or how does it exactly
For me, if your extreme bit is, let's say if your num parents is 3, then you're
Yeah.
going to treat that extreme bit as a series of the same bit, three bits, right, as your parent. And then you check your
Mhm.
rules. So basically it's either 0 or all one. So if it's num parent one bit only, so it's just 0 or 1. If it's
Oh,
three
I see.
parents, it's just 0, 0, 0 or 1, 1. And so you check your rules, and so that's how you define the next extreme bit based on the rules.
So it's basically checking to see if each, I guess, parent, like pairs of 3, has a 1 or a 0 and a more.
So yeah, for num parents, if your num parents is 3, then you're going to have your series of an 8-bit rule vector, right? And it's a
Yeah.
Boolean. So if your extreme bit is 0, you're going to check the 0th bit of your rules. If it's 1, then you're going to append all ones for that extreme bit. So that's 7. So you're going to check bit 7 of your rules vector.
So basically, it's wherever there's a 1 or a 0 inside the rules. And basically,
Well,
it will.
again, instead of, sorry, I have to be
append a
clear,
1
like not
or a
0.
0.
If it's 3-bit parent, it's 0 or 7. If it's a 1-bit parent, it's 0 or 1. So,
Alright.
and if it's 5-bit, it's 0 or 1, 1, 1, 1, 1, 5 ones or something like that. But
Yeah.
anyway, the checker only checks 1 parent or 3 parents. So
Yeah, I already got like the rule function done, but yeah, I'm just at make engines.
Yeah.
Make next gen, yeah.
So yeah, whatever questions you have, just pose it in for that
Yeah.
or Reddit. But yeah, hopefully that's clear on the extreme bit.
I do have a question about Quest 4. This is my first time encountering this, so can anyone explain what, like, for example, for a friend of stream, does anybody know what the friend, like, in the beginning is? That's the first time I've seen it before.
I think it it's supposed to be like it's external to the actual class definition, so like you can use it in the context of other classes, but it's supposed to be like inheritance. Like I don't know exactly.
It's
But
not
I assume
inheritance. It is
external.
it is external, like you were saying. It's basically the friend designator just says that this other class, I am giving it access to all of even the private member variables of this
Oh.
class. So
Okay.
that if you're, if you're filling out a OStream function or whatever your friend function is, you don't have to write, automaton dot blah blah blah. You have direct access to it within those functions, so you can just say sibling or child or whatever.
Okay. Yeah, that makes a lot of sense.
It's interesting that that's the only overload operator that was set that was declared as friend, while the other ones weren't. So I'm assuming the tester is trying to access the cout for that, or that friend operation, but since it's coming from another class trying to access this, but I don't know. I don't know why it wasn't a friend for the other overload operators.
Because
I
in
will
the other
answer.
ones, there is a way to write OStream overloads without them being friend functions. But basically, when you're overloading an operator, you have to think about what the left-hand side and what the right-hand side is. Like, if you were saying node equals node, both of those things are nodes. So it doesn't have to be friend, because both of those things can directly call on their private member variables.
Okay.
But in the case of like the OStream operator, your left-hand side is cout.
Right.
Your right-hand side is whatever you put on the other side of less than.
Okay.
So that has to be a friend in order to be able to directly access the member variables.
Okay.
Does that make sense?
Yeah. Okay. So yeah, again, I don't know. Antonio, do you have more questions about that Quest 4?
No, that's the only question I have so far. I'm just started today, so I'm still looking over through everything.
I'm on the basics of Quest 4, because it started going into the explanation of they started with a binary tree, and then they get into the general tree. And what if you want more than to it. I think it tried to get into more than 2 children for a particular node. So how do you? So I started getting confused on what they're trying to get at, because they're saying instead of 2 children, you have a first child and a sibling. But then I got confused with, okay, so what if you want more than 2 children on a node? But it still seems to reference only 2 children per node. Am I misunderstanding the whole concept of this quest?
I'm still like understanding on my end as well, so forgive me if I'm wrong a little bit. But from what I understand is that, let's say you have parent and then 2 children. The first child would be, for example, just if you look at the general tree,
Yeah.
there's 4 objects right there. Let's say the first child is the one on the very left. It would then have those next children as well, compared to the 2 in the middle where they're just siblings. There's no offspring for the siblings. At least that's how I interpret it. Again, I
Okay.
may be wrong.
See, I want to share like that part of the spec, like where I got really confused. Let me see. Let me see if I have it. Let me just share my. Here it is. It's this one. So if you could see it. So it started, this is where I got so confused, because they show the general tree and then a binary tree below. So obviously the root has 4 children. And so are we trying to code it in a way that you don't want to limit yourself to just 2 children? You can put in as many children as you want per node or per parent. But then it goes into like, oh, oops. First child, next sibling. And then when you see your private, when you see the struct node, all you have is, for each node, you have a child and a sibling. And I thought, okay, how are you going to draw a general tree where it has 4 children? Maybe I'm overthinking something, but I don't know. I was trying to get the point of this assignment, like to create a general tree without being specific to just 2 children.
If you look at that, just posted in the chat about
Okay.
the left child, right sibling representation tree. If
Uh-huh.
you scroll down on that page a little bit, or just click on that picture that I replied
Picture.
on it,
Okay. Let me see.
that is what you're doing. So every parent only has 2 pointers. They have a pointer to their first sibling, if it exists, and they have a pointer to their first child.
Okay.
So theoretically, like if you look at that picture, A has 4 children, 4 direct children, not grandchildren or anything. But it only has access to B. B is what you would get from the child pointer.
But are you looking at
in the
this
node.
picture here? Oh, here we go. This I don't know if you see.
Oh, sorry.
Is it A, B?
Yes, that's a good picture too. Yeah.
Yeah.
Okay.
So A only has direct access to B,
Okay.
but technically B through G are all A's children.
Right.
But the only way you could access C, D, E, F, G is through the sibling pointers of B. Does that make sense?
Oh, so sibling pointers. Okay.
So like when you say A
Oh, right here below.
dot
Right.
sibling, you
Okay.
only get B. Oh, sorry. Yes, that one that you're looking at right there.
Ah.
And to get to C, you'd have to say, A dot child dot sibling, or sorry, arrow sibling.
Okay.
Does that make sense? So all
Yeah,
of B through G are all A's children, but A only has direct access to B.
Okay. I'm trying to figure out, as a data structure, you would have that link list. Maybe let's say it's a link list, A, B, C, D through
Yep.
G. But then when you have D, if you hit D, maybe that's a separate link list or something to get to H.
Yeah.
I don't know.
Yeah, it's a series of linked lists. Each sibling pointer and child pointer for each node is a linked list, basically.
Okay.
So that you can continually add siblings or children, and this child could have a child, and that child could have multiple siblings.
Okay,
Sort of like opens it up
So
as
to,
far as being able to add things easily.
all right.
so to clarify, so each object, so we have all of these are its own linked list, but each linked list is pointing towards, as a node, the next linked list. So A is pointing to B, which can be a linked list, and then P points to C, which can be linked list. But it doesn't have to have its own next node. It can just move on to the next child, correct?
Yeah, I think so. Basically, each node has two pointers to linked lists, either children or siblings, and those can expand infinitely.
Mhm.
And so, C in that picture does not have any children, but it does have a sibling, but it can only directly access D, which is, yeah, you could think of it as the head of another linked list of siblings that goes D, E, F, G. And D has access to, or like E has access to a linked list of that points to its first child, which is I. J is its sibling. It's very confusing, but that is a good picture for what the general structure should look like.
Okay. Right, which
But
should
the-
reflect the top picture. It apparently the bottom one should reflect the top one.
Yeah, and it does technically, but like
Yeah.
in the top one, you would have to, A would have to have first child pointer, second child pointer, third
Yeah.
child pointer, all the way
Right.
to G. But
Right.
in the bottom picture, it only has a pointer to its first child or its
Okay.
first sibling.
Okay.
The thing that gets really tricky, and I haven't really figured it out fully yet, is when you're inserting children or siblings, the specs talk about basically it would pass in a node pointer called P. And you can't assume that that node doesn't have children or siblings of its own. So you could imagine that that P was like generated separately. But then if you're inserting it into your current structure,
Yeah.
as say a sibling of A in that picture, then I wasn't really sure, because you can very easily get into like two pointers pointing at the same thing with that. And so it seems like you would have to sort of recursively go through the entire structure of P,
And
make a
sure.
new structure that's
Oh,
attached to A, so that, because if you deleted P afterwards, because the user will still have access to that, then if you had just done a shallow copy, then all of that would be destroyed in your main structure.
mhm.
So I haven't really done that yet, but it does seem like you have to do some like pretty intense copying with the copy constructor, or maybe the
Right.
assignment operator or something, just to make sure you don't get any broken pointers.
Oh man. Okay.
It's really difficult. And then
Okay.
I wish
Oh,
our And was here, because I want to be able to just test my insert sibling and insert child and make sure that those, are written correctly before I move on. But I can't really tell if when I upload my files to the code request, if because I don't have the assignment operator or the copy constructor created yet, if it's like, saying that I've got broken pointers because of that, or if it's saying I've got broken pointers because of what I've written.
I think
So
for the insert sibling and the child, I did it, and I don't think you really have to use recursion for it. At least I was able to do it like iteratively, because
okay,
I think it's just like because you're inserting it at the end, like you don't really care if P has its own sibling or child, right? Like you just have to make sure that the thing that you're attaching it to, like it's at the end of that. So you kind of just have to like go through to the end and just like attach it there.
so did you make like a copy of the structure that P has, or did
Um,
you just directly like pin P onto the end, because since it says you return P, I was thinking that, then if you deleted that, basically you would have two pointers pointing at P and the structure that you just inserted, and that could get destroyed.
I don't think that affected it. I think like you just can return P at the end, and then all you have to do is like attach it to whatever node you're calling it from. And then at that point, like it's like part of that linked list, right? And then when you return P, it's just like your last, it's a pointer to it, but it doesn't really affect the rest of it.
Okay. I've been like trying to draw it a lot because it's pretty confusing.
I think, yeah, like the insert sibling does most of the work, and then you can like use that in insert child too.
Right, yeah. It's very confusing.
You know what? Now I'm going into insert sibling. Let me go back to that. What was it? So if you so the instruction said insert sibling, which is you navigate to the last node. Insert child is at the current node. So if I, oh my goodness. Okay, so going back here, if I want to insert a sibling for A, it would be appended to G. Is that right?
No, that would be if you inserted a child.
Oh,
A doesn't
so that
have
would go
any
to G.
siblings,
The insert
so
child will go to G at the end of G, or sorry, there'll be a line coming. It'll be A. So insert
G
child
is
would be
sibling.
here. But insert sibling would go where for A? It's so confusing now.
Like the line between B and C. C was inserted as B's sibling.
I don't think A has a sibling in this.
Yeah, A doesn't have a sibling.
It's like the root
Oh, I
of
see.
it.
B is the only child. Okay, so the sibling would be coming out of A.
Yeah.
Another new, okay. All right. And then let's say if it's C, D would be the child, and then C, if you insert sibling, will come out of somewhere here.
Looks like D points to two different nodes.
D is
C's sibling.
Yeah.
Yeah.
D is C sibling.
So like all of them in the same level are like siblings of each other.
Yeah.
It like starts
I
at B and they're like all siblings. Like they
But
go
I can
through.
insert a child for C, right?
You can, yeah.
Okay, then it would stick out here.
It would stick out one down, but if you wanted to
Down.
insert two children, it would stick one down and then it becomes like a sibling.
Okay, so if I insert a child for C, it will stick down here, but if I insert a sibling, it would go to G for C? I don't know, I'm so confused now.
Yeah, I think that's
Oh,
what happens.
Is that right? Okay,
Yeah.
it'll go to
Oh, that
G.
sounds right.
Jeez, all right. Okay, I hope I got it, all right.
Yeah, this is pretty, I think once you get past the functionality of like the copy constructor and the assignment and the inserts, and the rest wouldn't be too difficult, but
Okay,
those are what I'm struggling with the most right now.
let's insert, God, I hope I got, okay, if I insert a child. Jeez, okay.
Because I think the thing is like you can't directly access all of those, right? So you wouldn't really access like G directly. It'd be like you would insert a sibling for B and then it would have to go through the entire linked list and do it at the end.
And you didn't do it recursively or anything? It was an iterative process. Just to insert a sibling, you would go B, C, D, E, F, and then if G is the last. Okay.
Yeah, I didn't have to do recursive. It's just like kind of like if like the linked list like going to the end, like kind of like appending onto a linked list, you just go through the end.
Oh, okay.
And like for example, G has no siblings, right? So if you're going through B, like the linked list of like B siblings, like G's sibling is like null. So like that's like the end of it. So you can just attach it there. Like if you wanted to attach a sibling called like 1, it would just go there.
Actually, that's an interesting. I don't know why I said G was the last. N would have been the sibling, the last sibling, right?
N is G's child, I think.
Yeah.
You see, that's see, that's the thing. Maybe because it's going down visually. So, and ends up being the child of G, but that's interesting. So the sibling of G would, no, that would still stick out of G for sibling. Okay. Okay.
Yeah, I think I sent like, yeah, in the chat, there's like a Geeks for Geeks that kind of goes through how this representation works, which helped.
Oh, sorry, which one is it?
In the chat, I sent
Okay.
the
I know I'm gonna
child
get
and
that.
sibling tree representation.
Okay, let me try and record all that. All right. This is probably the same page, right? Oh, this is different. Okay.
The thing I was like just
Oh,
struggling
that's
with,
not that's different.
is because P is returned at the end of insert sibling or insert child. Say you can you scroll back to that representation you were looking at of the tree with the siblings and the
Here, this one. Let me get out of here. There we go.
yeah, exactly.
Yeah.
So like say like at the very you've got this representation. When you inserted G as a sibling of F, well, of B really, it went all the way to the end of that. It inserts it. It also technically inserts that G has a child into this structure. And then it returns that pointer P. So you could theoretically use that same pointer and say, okay, I want to insert that same pointer again as another child. And are we supposed to say, oh no, that child already exists, so you can't insert it? Or are you supposed to just copy the data of each of those children and siblings or whatever is attached to P and make another one that looks the same but isn't the same? Because then if you like you were saying, you just sort of directly put it on the end, and then it gets returned, if you deleted P, then it would not only delete that new child that you just added, but it would also delete the last version of it that was inserted. Does that make any sense?
You're saying that like once you add it on and after you return it and you delete P, then it deletes the thing you just added?
Let me share my screen. I have this really bad drawing I can show to elaborate. How do you do that? The sharing screen thing.
It should be
It looks like it's a
bottom.
green button on the bottom. Or
Okay.
Alt S, it says.
Yeah.
Maybe we aren't allowed. Okay.
There we go. Can you guys see this? Okay, so this is my bad drawing, right? So basically what I'm thinking is like when B got inserted, it returned pointer to this structure, the same pointer. So then you could theoretically, like you could call this in a loop, A dot insert sibling B. Sorry, it's kind of like messed up, but you could call that again. And this is after you've already inserted C as a sibling to B. Should it start walking through and then it sees that B is the same, it's the same address as the thing that's pointed to, so it doesn't insert it? Or should it go to the end and then create a matching structure, but it's not the same pointers? That's why I use different colors here.
I didn't do anything specifically to handle that. So I'm not sure what exactly happens. I think because it's the same pointer, I'm not sure if it would add it to the end or not. But that's a good question. I'm not sure. Like I got some points for the functions, but like I don't know like how many points like are total, but yeah. That's a
Because
good
the thing I would
question.
be worried about is like, if this wasn't different, if these are the same colors as these in my visual here, then if you were to delete this one, it would also delete this one. You know? Does that make sense? Like, because
Yeah.
when you inserted this one, it returns a pointer P to the caller. And then if you said, okay, if you hadn't done a deep copy and this was actually just a arrow that goes back to this one like this, because they're the same, instead of doing a deep copy, then when you deleted this one, it would delete this whole thing actually. Does that make sense?
Oh yeah. I see what you're saying.
So that's why I was thinking you have to do, you either have to like say, oh, this already exists, so we're not going to insert it. Or you have to do a deep copy of that whole thing that's being inserted. So
Or
that it's like this instead of like this.
would it, mm, I don't know, maybe like, does it matter if we're doing that? Because like technically P is its own node, right? So like it would just be sort of like adding the same thing again. Like it's like if you wanted to add two nodes with the same data.
Well, because so P has a child pointer and a next pointer. Like here, theoretically, can you hand me my pen tablet? Sorry, that was probably pretty rude for everyone watching that. Let me just draw this really quick. So when you're inserting this, say you had kept the node pointer to this after you had inserted it, and you try to insert it again. B's child pointer points to E always. So you would get into the situation where you would make a new B, but its child would actually point to this one. So to avoid that, you have to do a deep copy and just get the info of E and put it here. So it looks the same, but it's actually different. So that way, if it had been like this, and you say, okay, sorry, this is like so terrible. If you had kept this pointer that gets returned here, and you said P dot or delete P, then it's going to delete this as well. And actually, it'll delete this too. So then you lose access to C. So you have to do this like deep copy, or I thought you would have to do this deep copy where you, instead of just directly appending it, you have to look at all of its siblings, all of its children, and make this new structure that matches. Does that make any?
And so this scenario is like if the user takes the inserted node P and then just like deletes it, or like tries to insert it twice.
Yeah, it tries to insert it twice.
Okay.
So
I
like
see why that would.
if you called this twice in a row with the same node and everything, then you would get this double pointer issue where you have multiple pointers pointing to the same things.
Right.
So if you
I
were
guess
to
like
delete this one on the end, it would actually delete this whole structure, and then you would lose access to C.
right. I mean that it's not good to like that undefined behavior exists. And I mean like I didn't do anything to like work around it. I will say though that like the saving grace of that is the fact that the node like struct is a private member of the tree class. So in theory, like you control the insertion of nodes. And so there will never be like an opportunity like for a user to insert a node themselves without going through your public tree methods. But yeah, you're right. It definitely could pose a problem. I found that the reason that he's returning P is it makes it really easy to like link methods. So you can just do it on one line where you just like insert siblings or child. But yeah, you should point that out to him. I mean,
I did.
it's within
He
the
was
struct
basically
itself.
like, try it yourself and see if.
Yeah, I think I saw that. Like within the struct itself, it's a problem. Like if the node was public, it would potentially be like a huge issue. Like you could totally fuck up your data structure with like just a single delete. But I think because it's within the context of being like a private struct for the tree class, it should be okay. But I mean, if you find any holes within the tree class, I'd be really curious because that was an interesting find.
Yeah, well, the whole reason I got onto that was because I was reading through those the modules that were added, and there is actually a whole section on this. Section 9 is about this general tree, and if you look at the let me share this. If you look at the class that they've made for their thing, they actually have this clone function.
I can't see anything, by the way. I don't know if anybody else can.
Me neither now.
Okay.
Oh, really?
Mm-mm.
Yeah, it's
Well,
just
if
black
you-
screen.
That's so weird. Can you see this now?
Mhm.
So they've actually got this whole clone function that does this like whole recursive thing where it seems like it clones all of the siblings and it clones all of the children. And so that the thing that gets added when you do, I don't know if it's called insert here, is actually a clone of the node that you're putting in, not the actual thing. That's what got me onto this whole idea of it being a deep copy instead of just appending that pointer on the end.
I guess you very well could just make it a deep copy. I don't see why. I don't think it would change. It would change, I guess, its behavior here, but I don't see why it would change. Like it would still work if you used a deep copy.
Yeah. I don't know. That's what I've been stuck on for a little while. So I didn't try anything simpler like the specs say, where you can sort of just like get away with it, just
Yeah,
doing like a direct assignment.
that's certainly what I did.
Tend to overthink these things, but maybe I should try that first and see the limitations that adds, and then maybe add on to it.
I wonder if he'll expand on this to have us do like removals or like other changes to the tree. Because right now it seems like it's just construction. You do like one equality and then you like build your own tree. But you have a deconstructor, but there's no like targeted node removal.
Yeah, that's a good point. Because that would get into sort of what I'm talking about, where if you were trying to remove one of those and it was a duplicated pointer, then it would cause an issue.
Right. Yeah. So maybe quest 5. I don't know. I mean, I don't know. I have no idea what the future holds. I haven't finished this one yet, so.
Order 66.
Hopefully not. Okay, so really quick.
I do
Oh,
like
go
that
ahead.
idea of a midweek meeting, if we can figure out a
The
time.
midweek meeting.
Yeah.
Do you guys like this time? Like, does this work for you guys as well? It works for me. 8 o'clock is fine with me.
Time's great.
Okay.
Yeah, that's good. I'm good with that.
Wait, Wednesday?
This works for me as well.
Yeah.
What time?
But when I said 8 o'clock, sorry, I meant 6 o'clock. Your guys' time. I just got a little fumbled. Okay, yeah. What do you guys like? Wednesday, Thursday, Friday? Like, what do you guys think?
Not
I probably-
Wednesday. Friday.
Wednesday. Wednesday or Friday is probably what I'd say. What do you
Friday
guys
is
think?
fine.
Friday, because then we
Friday.
can work on it. Yeah, I would say Friday sounds good.
Okay. Does
Not
everybody agree with
Wednesday.
them?
Not
Friday?
Wednesday.
Not Wednesday? Okay. So I guess Friday it is, speak now or for hold your peace. It sounds like this meeting would be like somewhat optional. It sounds like this is the one that he has. I guess we could do two. So, okay, I mean, he'll probably watch this. I guess I could send him an email. Talking about Friday, and then I'm sure. So I guess so long as he opens this room, then we should be able to all join them for Friday, I would think, right? That's how that works. Okay. Okay, so I'm just sending him an email then to meet again next Friday.
Yeah, this will help
So-
because there's a midterm coming up, right? So
There
I'm
is, I
curious how
think
this.
so.
I think it was on the 18th. I think, and
I
It's
think
on the
it's next
18th?
week.
Okay.
whoever has
Oh, wow,
experience
okay.
in his tests, and so it'll be great to get some pointers from people who know his class. So yeah.
It's I mean, in the age of the internet and ChatGPT and compilers, he's got to make them pretty tough, and they are pretty tough.
Yeah, it's definitely like you can just know things to the best of your ability because the questions will make you think, and it's not something you can just look up the answer. Even like with your compiler, just like I can test this right now. It's thinking through things.
What do you have access to? Like, are you have access still to you have access to writing code on your or is it all these restrictions?
You're not supposed to. So
Yeah.
like it's just a Canvas, like a quiz, like the Canvas quiz like we took. It's just like that, the questions and like long questions, like
Okay.
not straightforward.
All right. Okay. Okay, great. I'm glad we're meeting on Friday. So, all right.
Last class, he posted these practice exams that were kind of hidden on Canvas, but I thought were super helpful. I don't know if he's going to post those again. But
Oh, I think I
they
remember
were,
that.
yeah,
Those
I
were
think they
nice.
were like, they had a weird deadline, like you could only do them during a certain time.
The day before.
Yeah, like the day before you could use these practice exams and it was like 20 questions, sanity check. And some of the questions were the same.
There is
Yeah,
a
they
beginner
opened-
practice. There is one.
Yeah,
Oh,
there's
there is
one.
one?
There
That
is
sounds
one.
like a plan.
It
That
opens the 13th, so this or I guess on Sunday. So it's
Opens
midnight.
Sunday and then closes the day before.
Mm.
So yeah, I definitely, that helped me a lot. Probably.
It gives the idea of what the type of stuff he tests, like the form of the questions.
All right.
Okay, so really,
Question.
this is
Oh, but if you have like an actual summary, I just have like a blast from the past question, but you can go ahead first.
okay. I just really quick. So Namrata, you said that you had submitted successfully.
Yeah. For
I have
this
my
piece.
whole thing like built out, but it keeps telling me that I redefined the tree class, and like I copied it from spec. It says, yeah, error redefinition of class tree. So, I mean, like on the spec, there's like these little to do sections within the header class, and like I filled out like the little, the little constructors. There's just the little assignments. I filled it out on the header, and then when I compile the file, I get no problem. So like, what do you think that could be? I guess like if anybody has an idea. I mean, like I could be just missing like something super small, but it's not a syntax error because like VS Code would tell me like, oh, something's wrong.
Did you import like the header into your main, like the main CPP and do that?
Yeah, I said
Does-
hashtag include tree.h using namespace std.
I'm not sure why it's saying that you redefine tree. Usually that happens for me if I forget to comment out main, but usually like when I try first submitting, I like make I like write out all the functions and just give like dummy return values. Because usually
Mhm.
like it doesn't like it if you don't actually have something for the like a definition for the function. I'm not sure if that
Yeah.
might be the case.
Maybe I'm missing a definition. That could be it.
Did
Okay,
you say
I'll look
you
into
did
it. I
some
just
of them in
yeah,
the header file and some of them in the CPP? Is that what you're saying?
What? Sorry, can you repeat that?
You said you did some of the definitions in the header file.
Yeah, like for example, like the general node constructor. I just did like that little tiny shorthand thing, you know.
Yeah, but you don't
that's-
also have that in your CPP, do you?
No, I don't have it. I don't have it defined twice. That was something that I did have, but the compiler picked it up. It was like, oh, you're redefining. You're like overloading the definition or whatever. Well, not overloading. Overloading would mean it's successful. You're overriding the definition.
Hmm.
So
I'm not
I
sure how
honestly
it's
like
doing that.
I'm super lost. I have no idea why it's doing this.
Did you spell things correctly? I think once I got an error because I didn't spell the thing correctly.
That's a good point. It would cause me. I would have to have
What was
spelled it
the error
incorrectly
again? Did
twice.
you say redefinition of tree?
It says so the actual error says so in the file included from test.h. So he has his files and then he has like test.h and my CPP, and then he says within tree.h 12.7, that's the start, class tree. That's the beginning of the class definition. It says error redefinition of class tree. Wait, is it just a space? I don't understand. I don't know what it is. It's like pointing to
Could you
the
send a picture
word
of it?
tree, like the T, and it's saying like it's wrong.
Yeah, why don't you share it? If you, I mean, well, you don't have to share. It's just the header file. Is it
I'll
okay
put
to
away.
share?
Hold on. Let me close VS Code and then I'll just share my Google screen.
Yeah.
So it's this, like so it's pointing to this T, and so like, is it because I'm including extra space here or something that I'm just not seeing? Like
I don't think that would be a problem.
I know because it's like I mean, C++ is like a I don't know what you call it, like a bounded language. Like it's not space. I have no idea why it's doing that though. Like, and I look at this error and I'm like, what could possibly be the issue?
I think Jonathan just put something in the chat that might like the IFN def in like the beginning, like the definitions and like the ending of the header might be it.
Maybe you forgot to end it. Did you do
Oh,
like end F?
I think this is totally a shot in the dark, but on Quest 2, I
Please.
maybe had something similar.
uh-huh.
And I included, I used the if no definition, define, sorry, if no
God
definition
damn it.
define this header.
Oh, that's totally what it is. I don't have the end if. Thank you, John.
Yeah.
Holy
Oh man.
God damn it.
Yeah.
Okay.
Oh yeah, you forgot the end if.
I did. Oh,
Well, now we
Alright.
know. That's a good thing.
cool.
Like that's
All
what it
right,
shows.
cool. Thank you very much. Okay.
You
for
can
sure.
also just do pragma
Yeah.
once instead of the if and def. And
You do what?
Pragma once.
What
And
is
you just
pragma?
put that-
Familiar with that.
I don't actually know what it is, but it's a newer version. If the whole if and def, define and if thing is like an older version of this, and now you
Yeah.
just do pragma hashtag pragma once like that up at the top. I normally do both because that's how I was taught, but you can just do that and you don't have to worry about the end if.
So you just write the word once, you just say hashtag pragma once.
Yeah.
Huh.
It's like
Just-
a
Either way
Right.
that works, I guess. Like whatever works, basically. Just use that.
Save my butt, man. I have this habit of like when I get stuck on something that's like kind of silly, like that, I'll like just stare at it for like 2 hours. That is not good advice, you guys. Just walk away.
yep.
Yeah.
I'll start trying things where I'm like, I have no idea if this will work and I don't know why, but at least it's something to try. And then usually like the third one of those will do something that will, yeah.
Yeah, I had the same kind of deal with the conversion. I was using the function string to int from the string library. And it was just that, like, it was giving me an exception because I guess I was basically making it converting the string to an int instead of, like, I guess appending it to the size t, yeah. The size t variable that I created. So it's just like the whole thing. Like, it technically worked, but like the auto grader did not like it because I guess it would cause issues later down the line.
It's just like I think it's just a warning, like if you compare different types. But yeah, it seems like it should work. But that was something that really screwed me up when I was taking 2A, is like, you get used to always opening up your for loops with like integer I, but then if you're doing sizes, you have to do size ti. Yeah, that would trip me up for a little while as well.
I just looked like in the conversion functions for like the string library, and then I decided to go string, yeah. Because like I would still use the string function to convert to toString, right? But then I'll convert that toString to whatever the I guess the type is, like, universally.
Yeah. Okay, Erica, sorry for taking your spotlight. Shoot.
Don't even worry about it. I think I was having some Wi-Fi issues, so I'll watch the recording, and I was probably freezing. But so yeah, I'm starting quest 3. Don't have really questions about that because I'm still just reading. But I did post this morning about like cache issues. And I think Ryan, like you said something about using the recursive nature of the function to maybe resize. So are you implying that maybe I should be resizing during the because what I was trying to do is just kind of keep it a little like separated and cleaner. So it's like, oh, here's all the recursion, and like here is all the cache, resizing and like inserting and stuff.
Yeah.
Underneath it.
Were you resizing the cache like iteratively, like you were just building out the whole thing?
I think I was. Now that you mentioned that, when you mentioned trying to use the resizing the cache recursively, I was like, wait a second, I wasn't doing that.
Yeah. So that was something that took me a while to figure out, was like it makes more sense to just build out the cache like intuitively, just like iteratively, just like go through all the different sizes you need, just several for loops and just build it out. But the recursive function is basically like several nested for loops. And so you'll find that you can build out the cache in a way that he described as like lazily, like you only size it to the size that you need it, versus like doing like eagerly, where you like build out the cache first and then you input the values. So you need to find like the spot in the recursion where you'll do it, and then just make sure. That's why I made a point about not downsizing. So just make sure that at no point, like if you go from like 312 and then you go from 132, that one in the source downsizes the size of the cache, because then you'll lose values.
Okay, awesome. Yeah, thank you so much for the help. And so like in the spec it said, right, like it's that last cache cart is all, it's kind of an all or nothing thing. So I guess I don't really know if like lookup is working, if things are working correctly until cache is not overloading memory, right? Is that kind of how it worked for you guys?
Are you asking like how to test like the like whether the cache is filling correctly?
I guess like I guess like in like the fourth, so for the memoization, it's like a couple, like it's like for the first 3, like get moves, like original get moves is working, then solve is working, and something else, yeah, and the base case for get moves is working. And so the last one, it's look at moves, and then changing get moves to do the cache sizing, resizing, and saving.
Yeah.
I was just like as a side thing, lookup like, because when you use lookup moves, it's on your own cache, right? So if you're not saving and your cache isn't functional, then lookup moves also, when he tested, isn't working, right?
Yeah, that sounds right. Yeah, I agree with that.
Okay, cool. I was just a side curious thing. But thank you. Thanks for the help. Questing.
Happy to do so.
Well, it looks like it's time, huh?
Yep, that's it. So sounds like Friday again, you guys, same time, 8 o'clock.
Yeah.
So do we
Six.
still use the
Okay.
same,
o'clock.
are they gonna post a Zoom meeting ID or something, or?
I think so. I think it'll probably be the same room. I guess I'll just send them an email. We'll probably see
Okay.
it from the recording, but
Okay, all right, sounds good.
All right. See you
It
guys.
was 6 o'clock, right?
All right, thanks, everyone.
yep, 6
Yeah,
o'clock.
same time.
Cool.
Okay,
All right.
Great.
bye guys.
Thank
Good
you.
luck,
guys.
Bye.
everybody.
Thanks.